Hello everyone, welcome to this section. In this section, we are going to talk about exception handling in C++. In this video, we are going to talk about try, catch, and throw mechanism. So these are three keywords that we use in C++. But why do we use them and what are they in fact? So for example, if we want to start with the try, for the try, it contains the code that may throw an exception. So if an error occurs, control moves to catch block. So this is why we use try. And for the throw, it is used to signal an exception when an error occurs. So it translates control to the nearest matching catch block. And for the catch keyword, it handles the exception thrown in the try block and prevents the program from crashing. Okay, why do we use them? It allows programs to handle unexpected issues such as dividing by zero, invalid inputs, or file not found errors. So instead of having a program being crashed, we can have error handling to give us some output in the terminal so we understand there is an unexpected issue with the code. And also it helps to increase program stability, so it prevents abrupt termination of the program. And also it gives us a customizable responses because we can define how our program reacts to different types of errors. So let me illustrate all of this with an example. I'm having one function here. It is called divide. It's a void type, so it's not going to return anything, and it takes two arguments. And we are just saying that if b equals 0, we should have an error. So enter if, because if we want to divide a by b and b equals 0, it is not possible mathematically speaking. So if b equals 0, we want to show a message in the terminal saying that division by 0, error. So it's an error, okay? Otherwise, if b is not equal to 0, we are going to show the message in the output saying that the result is, and do the mathematical operation here, okay? Just ignore this throw keyword here for the moment. Just imagine that if b equals 0, we are going to have this message, and otherwise we are going to have the result in the output by dividing a by b. Okay, so in the int main function, I'm having my int main function here. I'm having two integers being declared and initialized. So num1 and num2 to be 10 and 0 respectively. But because I would like to call this divide function, and I think that it might be a risky operation to be done based on my coding experience, I would put the call of this function in a try keyword here. So I have the try keyword and I have the brackets here. Okay, so I call the function in the try block. Okay, because based on my experience, I think that this might cause some risky operations. Why? Because in some cases, I may not be aware that I'm putting one number to be divided by 0, so it's an error, and instead of having a crash in my program and have nothing in my output, I want to check to handle everything correctly and clearly and nicely. So I would like to check to see if it raises any problem or not, or if I'm making any mistake or not throughout my code, because I may have 2000 lines of code, and every time that I'm calling this function, I should be very careful that I'm using everything correctly. To check that everything is being done correctly, it's nice to have the try, catch, and throw mechanism. Okay, so this is why when I'm doing some risky operations that may cause problems, I put it in my try block as explained here. So in the try block, I'm calling this function and passing two arguments, num1 and num2. So num2 equals 0, therefore this is definitely a problem. So I'm going to call this function, and this function is being called. So compiler starts executing this. So it is accepting number 10 and 0 as the arguments, and it says, okay, the second number, which is b, which is num2 here, equals 0. Then if this happens, throw an exception. So instead of saying that cout and division by 0 error, just throw an exception here. Okay, so one more time. I start to do my risky operations using to call my risky operations in a try block. And in my function, if an error happens, I throw an exception by showing this message. Okay, and when this function is called and the execution is finished and an exception is thrown, then I'm having my catch block of code. Okay, for the catch block of my code, I'm having the catch keyword and then having this parentheses to be there. So constant character star error message. Okay, it catches and handles the exception. And in the block of the catch, I'm having a cout, which is going to print exception caught and then print out the error message. But what is this error message? This error message comes from the throw, because this is the message that I wanted to throw as an exception. Okay, so when I'm using the throw keyword, then right away start the quotes here, like you see here and here. Okay, this is called error message. So an exception is from. So when you are printing out the error message here, it is going to print out this message for us. And then in the end, I'm having the program continues after handling the exception. So let me review it one more time. Then I'm going to run the code and analyze the code further. So when I want to do something risky, so I know that I have a function that is dividing two numbers. So I know that mathematically speaking, if the second number is 0, we cannot divide any number by 0. This is a logical mathematical rule. We cannot divide anything by 0. Okay? So this may cause some problems if I'm not careful enough whenever I'm calling this function. So it's a risk. In order to catch this risk, I try to call this function in a try block. Okay, so anytime that I want to call this risky function that may have a problem, I'm calling it in a try block, and this function basically is called in the try block. When this function is executed, I'm saying that if the second number is 0, throw this exception, throw this error message. Okay, so if the second number equals 0, so if you're having another function doing another thing, just throw an error message if something goes wrong. Okay, whatever that is not going correctly, so whatever that you think that may go wrong and may happen, put a throw keyword there and then put this error message. Okay, then this error message is going to be executed and thrown if the second number equals 0. That's it. The execution of this function is finished, for example, now, because we entered this parentheses and we have thrown this exception. Then we are going to have the catch block of code. So the catch block of code, I'm having the catch keyword with this parentheses saying that constant char star error message. Okay, and then I'm in the block, basically I'm couting exception caught, showing the message, showing the alert in the terminal saying that okay, something wrong happened, and this is the error message, and this error message is going to be printed. So you may have different functions, like 2-3 functions, and for each of them you're having the try, throw, and catch mechanism. But when this error comes from calling this function here, you need to have this message here. But if you're having another function, for example, I was having another function here and I was having another throw message there. So when this catch function runs, this catch keyword block of code runs, another error message would have been shown. So I'm going to give an example in the next video about having two functions, for example, to see that having error messages are very important. So you can see, okay, this message comes from this function and there is another message coming from another function. So I can have this, for example, alert from function divide. Okay, I'm having this saying that, okay, this catch happened and this message comes from the function divide. So now let me run the code. Okay, so when I run the code, we see that we are having exception caught, division by 0, alert from function divide. So when I see this in the output, just imagine I'm having a lot of things in the output. I'm checking everything now. I see exception caught. Okay, what happened in my code? And division by 0 error. But if I only have this message, I need to think, okay, division by 0. I did the division by 0 in which function? What is the function that does this for me, etc. So I need to think and search in the code. However, I'm having this alert from function divide. Okay, I have a divide, I have a function called divide and division by 0 error. So in the divide function, I'm having this throw message. So let me go and find that throw message to see where the problem exactly comes from. So when I come to my code, I can see, okay, this is my divide and this is a division by 0 error alert from function divide. So okay, this message is being shown in my terminal, so there is something wrong. What is happening? When this message is going to be shown in my terminal, when b equals 0. So there was a time that I called this divide function and the second number was 0. This is why this happened. So I need to go to my code and check where I'm calling this function and where I'm calling this function with the second number equals 0. Okay, so when I come to my code, you see, I search for the divide function. I see, okay, in this example, I'm calling this function once, but I may call this function like 10 times if you have a lot of code. Okay, I search every time that I'm calling this function and I check the arguments where the arguments, the second argument equals 0. Okay, now then I can see the problem and understand exactly where the problem comes from. This is why try, throw, and catch mechanism is very important to be used in risky operations. Let me do it one more time. So I'm having the risky operation being implemented in the try block. I'm calling the divide function, and I'm saying that I'm going to have the result if everything is okay. So if b is not equal 0, I'm going to have the result here, a divided by b. However, if b equals 0, it means that there is a problem. Mathematically speaking, it's not possible. Then throw an exception saying that, okay, just show a message so that I know that this if is executed. This if that shouldn't have been executed is now executed. So throw a message. And then in the catch keyword block of code, in the when we are having the catch keyword in this block of code related to catch, we're going to handle that thrown message, thrown exceptions. Okay, so here I'm having the okay error message, and error message is basically what is written after throw keyword. Okay, so this is how we can handle errors and exceptions better in C++. In the next video, I'm going to provide you with more examples, so it would be a bit more clear how it is useful when you're having a large amount of code. So in the next video, I'm going to have 2-3 functions, and there I'm going to understand where I'm making the mistakes. This is very useful. Thank you for watching. Hello everyone, welcome back. In this video, I'm going to work with try, throw, and catch mechanism, but I'm going to have two independent functions and each of them are going to have their own exceptions to be thrown. Okay, so I'm having one void function called divide. It's exactly similar to the previous video's function. It has two arguments and it is going to divide A by B. So if B equals 0, it is going to throw an exception. Otherwise, it is going to print out the output of A divided by B. Then I'm having another function called access array. It's a void type, so it's not going to return anything. It has three arguments, this function. So the first one is an array, the second one is an integer, the size of the array, and the third one is the index of the element of this array. Okay, so if index is lower than 0 or index is larger than the size of the array, we need there is a problem, so we need to throw an exception. Otherwise, it is going to show out the index that is used to as the third argument, and it is going to print out the array index. So the element, for example, if I mention that the index 3, so it is going to say element at index 3 and then print out the element in the array with the index 3, okay, here. And if index that is lower than 0 or larger than the size of the array, it is going to throw an exception. I'm going to discuss this in details. And then I'm having one main function. I'm having two numbers, num1 and num2. So the first one is 10, the second one is 0. I'm having an array 1, 2, 3, 4, 5. So it has 5 elements and their index are, so this is the 0, 1, 2, 3, 4. So in C++, everything starts from 0. So this array is having 5 elements, 1, 2, 3, 4, 5, but the index 0 of the array is 1. So the element with index 2 is number 3, element with index 4, for example, is number 5. So when I call this function and I have the third argument to be index, so if I'm saying that, okay, index 3, it is going to investigate index is lower than 0. No, 3 is lower than 0. No, 3 is larger than the size of the array. No, because the size is 5 and 3 is not larger than that. So this parenthesis is not working for our situation. So this part of code is not going to be executed, and this part of code is going to be executed. So it is going to say, okay, you mentioned that index 3 and the element of the index 3 is number 4. Okay, so it is going to print out this one. And I'm calculating the size of the array using this formula. So I'm having the size of the full array divided by the size. So the size of the array will be the size of the array divided by the size of the first element. So this formula is going to give us the size value here. So the size of the array, for example, if the size of the array is, for example, 20, and 20 is divided by the size of the first element, for example, which could be 4. So 20 divided by 4, the result is 5. So the size of the array is 5. So let me give you an example. For example, we say size equals size of the array. For example, we say it is 20. And when it is 20, it is divided by the size of the first element of the array. And it is, for example, the first element size is 4. Therefore, size equals 20 divided by 4. The size is 5. Okay, so we calculate the size of an array using this formula. And basically, this formula is known and it is accepted everywhere. So you calculate the size that it takes the array divided by the size of one element. So you would this way you would see how many elements are included in that array. Okay, the full size divided by one size will give you the number of elements in that array to you. Then I'm having one risky operation, division. I'm calling it in the try block. So the divide function is called using num1 and num2. Num1 is 10, num2 is 0. So 10 is going to be divided by 0, but the second number, which is b here, equals 0. Yes. So therefore, an exception needs to be thrown because error in division by 0. So we are saying error in divide function, division by 0, it is not possible. Then when this happened, the execution of that function is finished and the compiler comes to this part. So we are having the catch. We are having the catch keyword here and the catch block of code. So we are having const char star message, and we are saying that exception caught and message. This message is exactly what is written here. Okay. After throw keyword, we are showing a message, and this message is basically this message that is going to be printed here. Okay, so the first function is called. Then I'm having another risky operation, and I want to call this access array. Why it's a risky operation? Because if the index is lower than 0 or equal to the size or larger than the size of the array, an exception will happen. So in order to make sure everything goes right, I call this function in a try block, and I'm passing the array, the size of the array, and the index that I'm looking for. Okay. So if I'm not correctly inserting this index, an exception will happen. So I'm calling this function now. So this function is being executed. I'm passing the index 7. 7 is lower than 0. No, so everything is okay. 7 is larger than size. Size, we calculated, it's 5. And the size and the index that I'm saying is 7. So it's not possible to have 5 elements and looking for the index 7. Okay, so it's a problem. If we don't have this message, it would be confusing to understand where the problem comes from. So I'm having this throw message saying that one of these situation happened. So either the index that you're passing as argument is lower than 0, or it is equal to the size or larger than the size of the array. And it's a problem because that index that you're looking for is not valid. And therefore, if this condition is correct, it is going to enter this if part, and it is going to throw an exception showing that error in access array function indexed out of bound. Okay. And using a catch keyword and the block of code of catch, I'm having this message, and this message is exactly this message. Okay, so now let me run the code. So when I run the code here, we see that, okay, exception caught. I'm having a problem in my code. So error in divide, division by 0. So now I see that there is an error in my divide function, and division by 0 is done. Therefore, an exception is caught here. So I'm calling the divide function somewhere in my code, and when I'm calling this function, I am dividing a number by 0, which is a problem. So I go to the divide function and I see, okay, this message is in this if condition part. So b equals 0. B is the second argument. So somewhere in the code that I'm calling this function, I'm passing the second number to be 0, which is a problem, which is not a valid value for the second argument. So I come to my int main function now. I see, okay, I'm calling this divide function. I'm passing num1 and num2. Okay, num1 is 10, but num2 is 0. This is not correct. So I made a mistake in my code. So now I put 5 and rerun. Okay, the exception is not there anymore. Instead, when I'm calling this divide function here, I'm having the result of division equal to 2. But how this happened? This is what I was looking for, in fact. The result of division, a divided by b, and a is 10 and b is 5, because num1 and num2 are passed to call this divide function, and this divide function is dividing a by b, which is 10 by 5, and the result is 2. However, I'm still seeing a message in my program saying that exception caught, error in access array function, index out of bound. So when I see this message, I right away go to access array function. So I come to access array function and I check it out here. Okay, error in access array. Where this message is in my function? Okay, I see that this message comes from this part. And when it comes from this part, it means that the compiler entered this if condition, because this message is inside one if condition. And I see that the index as the third argument that is passed to call this function is either lower than 0, or it is equal to the size of the array, or larger than the size of the array. So I'm calling this access array one time, and as the third argument, I'm not passing the correct number. So let me go now in the int main function to see where I'm calling this function and with which value I'm calling this function. So when I come here, I see the access array function is called here, and the access array function that is called here is passing 3 arguments. So the array, the size, and the index. And the if condition was investigating the index and the size. So the array we know, because this is the array that we declared and initialized. The size is calculated correctly. I check the formula. Okay, so the size of the array is correct. We can also see out the size of the array to check that it is calculating things correct. And I see, okay, it's not a big array, so I can do the calculation of the size myself. The formula is correct. The size is 5 and the size is 5. It's correct. So let's now check the index that I'm looking for. So I'm looking for index 7. But this array is not having an index 7. So this is the problem, because the size is 5 and I'm looking for index 7. So 7 is larger than 5, and this is why we enter this if condition, and this is why this is shown in the output. So I'm not passing the correct argument. So let me check. Okay, I'm looking for index 3. Let me recompile. So, okay, now that I recompiled, I see that no exception is there. Okay, so no exception is there, so the problem is solved. So the problem was an invalid number that I'm passing as the third argument for the index that I'm looking for. Now, 3 is passed, and 3 is lower than 0. No, 3 is lower than or equal to the size, which is 5. No. Is 3 larger than 5? No. Is it equal to 5? No. So this if condition is not going to be executed, and it is going to print out this line for us, which is the line that I was looking for from executing this function. And in this line, it is saying that element at index 3, because I'm passing index 3, and it says element at index 3 is 4. Why? Because I'm having index 0, index 1, index 2, and index 3. And index 3, the number is 4, and it is printing out that number for me. So this is how the try, throw, and catch mechanism can help us to understand potential problems and errors in our code. Thank you for watching. Hello everyone, welcome to this lecture. We would like to write a program that handles multiple exceptions in one function. So to do that, I'm having one function called check number. It's a void type and it is accepting one integer as an argument. And it is checking to see if the number is lower than 0, it is going to throw an exception. And if the number equals 0, it is going to throw 0. Otherwise means that the number is larger than 0, which is a valid number. So we are looking for a valid number that is larger than 0, and it is going to print out the number in the output. So if the number is lower than 0 or equal to 0, it's a problem, but if it's larger than 0, it's a valid number. This is how this function, this check number function works. In the int main function, I'm calling the function check number for the first time in a try block of code. I'm passing -5. So -5 is here. It checks, okay, -5 is lower than 0. Yes, so it is throwing an exception, negative number error. After that, we're having the catch block of code here, and it is saying string exception. By string, I mean an exception that is shown in a string way. So it's a string, it's a message. String exception, and then showing the MSG or message here in the output, and this is the message basically. And then I'm catching int e if number equals 0. So if number equals 0, we are throwing a 0. We are saying integer exception, and 0 is printed out here. So let me run the code. So when I run the code, I see that I'm calling the function once, and it is saying string exception, negative number error. So this check number function is called only once. And for two if else conditions, there are two different exception handling message here. We see the first one is negative number error, and the second one is 0. Okay, so when I call the function with -5, it is saying that staring exception, negative number error. So when I see this message in my output, I would say staring exception, negative number error. I go and check my program to see this comes from where. So when I search my code, I see that I'm having negative number error here in this if part. Okay, in this if part. So this has happened, therefore this is shown in the output. So why this has happened? Because num is lower than 0. So when I call this function, as the argument num is passed to be lower than 0. So it's a problem, it's not a valid number that I'm looking for. So I go and check where I called this function. So I call this function here. Oh yes, okay, see, I'm calling the function with an invalid argument. So now I call the function with a number that is not lower than 0, but it is equal to 0. So let me run the code one more time. So we are saying that integer exception 0, and we are having this 0 being shown in this throw part here. So when I see it here, it is happened in this if else condition block of code. And when it is in this block of code, it means that num equals 0. So num is the argument that is passed to this function. So when I call this function in my int main function, I'm passing the num equal to be 0, which is not a valid number, and I'm not looking for it. So I made a mistake. So I check where I call the check number function. When I check it here, I see, okay, I'm passing a number that is 0, and 0 is not a valid number through the definition of this check number function. Therefore, I need to change this. So I call the function. Now I corrected my problem, and now I call this function. I run the code one more time, and I see valid number 10. So I finally see the output. So this function was there to check out if it's a valid number or not. So no exception is caught, and no errors in the output in the terminal, and no warning, no alert. Therefore, everything is correct, and a valid number is printed out here. So this is how one function can have multiple exception handling message in the terminal, and they are very useful to check if we are making things correctly or not. When, as I mentioned earlier, when we have a lot of lines of codes, we need to follow this rule, try, throw, and catch mechanism, because it would help us to debug the program much easier as compared to the case when we're not using this mechanism. And also we learned how multiple exception handling is done in one single function, and I'm calling this function once, but I'm having the catch keyword block of code two times because I'm having two exception that might be thrown in different situations. So I'm having two catch keyword and two block of code for the catch for different messages to be shown in the output in case something goes wrong. Thank you for watching. Hello everyone, welcome back. In today's video, we are having an array called ARR. It has 5 elements, 10, 20, 30, 40, and 50, and the indexing starts from 0 and ends with 4. And index 4 means the 5th element. Then we are calculating the size of this array, and then we are having one variable of integer type called index. Here, we would like to ask the user to enter an index, and whatever the user is going to be entered, we are going to store it in the variable index here. And then here, for further information, I'm printing out the size of this array. Now, in order to tell the user, so the user is going to have this in the terminal. We are going to ask the user to enter an index, and we already defined and declared an array. We are going to ask the user to enter an index, and the user is going to enter, for example, index 1, and here I'm writing it here. Okay, the user is going to enter index 1, for example. Then, because the user may make a mistake, because the user might type down the wrong index, an index that is not valid and it's out of bound, we are doing something risky. Okay, so it's a risky operation because the user of our program may make a mistake. Because of this possibility, we need to use the try and throw and catch mechanism. Okay, so in order to proceed, we are going to have the try, throw, and catch mechanism, and the try block starts here. So I have the try keyword and then the block here. So we check if the index that is entered by the user is lower than 0, or the index is larger than or equal to the size of the array, throw an error. Okay, throw an error. If this condition is true, throw an error. And if this condition is not true, simply just type down this message saying that value at index, for example, 1, and call that element. So we are going to type down the name of the array and then put the index in parentheses here. For example, if the user enters index 1 is for the element 20, and we are going to have 20 in the output. So let me run the code once. So enter an index. Okay, this is this message being shown. I say, okay, I would like to have the index 1 being printed out in the output. First of all, it shows me that the size of the array is 5. This is this part of the message that I wrote. And then it says value at index 1 is 20. Okay, so value at index 1 is 20. We didn't throw any exception because the index that we entered was not out of bound. But if we enter something that is out of bound, it means that we are entering an index that is lower than 0 or larger than or equal to the size of the array. So larger than the size of the array, it makes sense because we cannot have an array with 5 elements and ask for, I don't know, the 20th element. Okay, so if it's larger than the size of the array, that the index that we are entering is larger than the size of the array, it's a mistake. So it's out of bound. We need to show this message. But why it should not be even equal to the size of the array? This array, we calculate the size. The calculated size was 5. Yes, it has 5 elements, so the size is 5. But the indexing starts from 0. So the last element, the 5th element, is having index 4. At maximum, we should be able to enter index 4. Okay, 4 is larger than or equal to 5? No. Therefore, and 4 is not lower than 0. Therefore, we are not going to throw an exception. Okay, so the maximum index that is valid is number 4 because the last element of this array is number 50 and it's the 5th element, and the index of this 5th element is 4. Okay, but if I type down, for example, 5, the index 5 does not exist in this array, so it's an exception that we need to throw. It's an error. Okay, so this is why the maximum index that should be entered is the size of the array minus 1. So this is why even the index cannot be equal to the size. So if I type down index 5 and the size of the array is 5, we don't have the index 5 here. Why? Because we start from 0 for indexing. Okay, and in case that the size we enter, for example, index 5 and the size is 5, so it's an exception to be thrown, we are going to throw this message, error index out of bound. Okay, so this one is a string literal. Okay, how do we know that it's a string literal? Whatever that is written after the throw keyword in C++, in quotes, right away in quotes, it's a string literal. And its type is the constant character pointer. But we don't need to type down constant character pointer because the compiler knows if a quote right away comes after a throw keyword, it's the constant character pointer. Okay, and actually this string literal is stored in a place in memory that is used for a read-only format. We don't want to change it. This is why it's in a read-only format. Okay, to review, in order to declare a string, we use the string keyword, then the name of the string, and then the code on the other side, on the right hand side, for example, hello world. But in order to declare a string literal, we need to use a constant character pointer and then the name of it. And then on the right hand side, we are having the, for example, the phrase in double quote. So after throw, whenever we are right away having the quote, it means that it's a string literal. And in order to call that, in order to catch it, we need to this time type down its type. So it's when this is why in the catch block, when we are throwing this exception in the catch block, we type down constant character pointer and then we name it, for example, e here, and we are printing e. Also, if I type down two e's, for example, double e, and I type down c out double e, it's okay. So it depends on you. This is not the important part. Okay, so don't worry about this part. The important thing for you to know is that it's a string literal because it comes in code right away after throw. So we don't have anything in between. We don't have another keyword, for example, a string here. Okay, so right away coming after throw, it means that it's a string literal. So for example, if I type down index 5, we see error index out of bound. So this message, error index out of bound, is thrown, and then using the catch mechanism, we are showing it in the output. So this is how it's going to work, and it's a very useful way to throw an exception if we are doing something risky or we know that the user may make some mistakes. So we need to throw an exception and let the user know that, okay, you're doing a mistake, the index is out of bound. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that takes an even number from the user. And then using the exception handling procedure, like try, throw, and catch mechanism, we're going to check if that number is really an even number or not. If it's an even number, it's okay. We mentioned that you entered, for example, 20. But if it's not an even number, we are going to throw an exception and then catch that message and show it in the terminal to the user. Here is my integer called number. We ask the user enter an even number, and then whatever the user is going to enter is stored in number. Then, because we are not sure that the user is going to enter the correct input or not, we are going to use the operation. We are going to implement the operation in the try block. So we say try, and in the try block here, we are having this if condition. So if the number is divided by 2, so if this number variable, okay, I'm talking about the variable. So if the number variable, so the number variable could be any number that the user enters. For example, I would say number equals 10. Just imagine that the user is going to enter 10. So if 10 is divided by 2 and its remainder does not equal to 0, throw an exception. But 10 divided by 2, its remainder is equal to 0. Therefore, this statement is not true. Okay, when this statement is not true, it's not going to throw an exception, and it is going to say, okay, you entered number 10. When I run the code, enter an even number, I say 10, and it says, and you entered 10. Okay, you entered 10. So 10 divided by 2, its remainder equals 0. Yes, but we are checking to see if 10 divided by 2, its remainder is not equal to 0. This statement is not true. Okay, but what if I enter 11? So if I enter 11 in the input, and then 11 is divided by 2, its remainder does not equal to 0, does not equal 0. Yes, this statement is true. 11 divided by 2, the remainder is not equal to 0. So this statement is true. Therefore, we are going to enter the if condition, and in the if condition, we are having an exception. We are throwing an exception. Why? Because this is not an even number. We asked the user to enter an even number and they made a mistake, and we are saying that error, invalid input, expected an even number. Okay, and when this error is thrown, we are having the catch block here to catch the thrown error. We learned that it's a string literal, so it is going to be of type constant character pointer, and we name it e, for example, and then we are printing out e here. So when I run the code and I, for example, enter number 11, it says error, invalid input, expected an even number. So this is how it is going to actually work for checking an even number using try, throw, and catch mechanism. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to work with exception handling. We are going to ask the user to enter a number, and then we are going to call a function to calculate the square root of the entered number by the user. And because we know that the user may make a mistake in entering a number, for example, they enter a negative number and it's not possible to calculate the square root of a negative number, therefore we need to use, it's better to use try, throw, and catch mechanism. So here is my program. Here is the number that the user is going to be entered. So this is of double type, and the name of my variable is number. Okay, so we can call it, for example, I don't know, we can say num1. Let's change it for the sake of simplicity. So num1, num1, and num1 here. Okay, so we are having a variable called num1. It's of double data type, and we are going to ask the user to enter a number, and we are going to store it using cin in the num1. Then we are going to use the try block here. Okay, we are going to call the calculate square root function and pass num1 as the argument. Okay, so whenever this function is called, this is the name of the function, calculate the square root, and it is going to return a double value for us, and it accepts one argument of double type as argument. So let's imagine that this if does not exist. So this function is going to calculate the square root using the sqrt keyword, and in parentheses we are having the number that is the argument of this function. So whatever the user is going to enter, this function is going to return the square root of that number. Okay, and then here we are having the cout saying that square root, and then the result is shown in the output here for us. Okay, so this is how we are having the output, and this result came from here, because when we call the function with num1 as the argument being passed to this function, it is going to return the output, and the returned output is assigned to the result variable, and in the next line we are calling the cout message, we are showing this in the output saying that square root, and we are calling the result variable and showing the output. For let me run the code. So I type down, for example, 25. It says the square root is 5. I type down 28. It says the square root is 5.2915. So I enter a number, it is going to store it in num1. It calls the calculate the square root function, and it is going to calculate the square root. It is going to return the output. The output that is returned is assigned to the result variable, and we are here showing the result variable in the output. Okay, but what if we make a mistake? So if the user enters a negative number, we cannot compute the square root of a negative number. This is why we are having the throw condition, throw exception here. So when we want to, when the function calculate the square root is called, before doing anything, we are having this if condition. We are going to check to see if the number is lower than 0 or not. So if the number is not lower than 0, it is going to calculate the square root and return the result for us. But if the number is lower than 0, it is going to throw an exception. Okay, we are going to throw an exception saying that error cannot calculate the square root of a negative number. We're going to throw an exception, and here we are going to catch it. And here we are having the constant character pointer because it's a string literal. And then we name it E, we can name it whatever. And then we are showing this error, the caught error in the output. So when I run the code and I type down -2, for example, -2 is stored in the num1. Then we are calling the calculate the square root function, and we are passing -2 as the variable num1 to this function, and we are checking it here. -2, is it lower than 0? Yes, this statement is true. Therefore, we enter the condition, and we are going to throw an exception. Error cannot calculate the square root of a negative number. And then we are having the catch block of code here that shows that thrown message in the output here using the cout and E. Here in the output, it is shown error cannot calculate the square root of a negative number. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that converts a temperature from Celsius to Fahrenheit. And we would like to throw an exception if the input temperature is below absolute zero minus 273.15. Okay, so here I'm having my main function. I'm declaring a variable called Celsius. It's of double type, and we are going to show this message to the user saying that enter temperature in Celsius. Then we are going to store whatever the user is going to enter in this Celsius variable. Then here we are calling the Celsius to Fahrenheit function. So this function is going to do the conversion for us, and it's of double type, so it is going to return a double, and whatever that function is going to return is going to be stored in a new variable called Fahrenheit. And then we are going to show this message in the output saying that temperature in Fahrenheit, and then show this variable in the output. Okay, but let's dive into the Celsius to Fahrenheit function. So the name of the function is Celsius to Fahrenheit. It is going to return a double, and it is going to have one argument which is called Celsius here. So we are going to pass the Celsius variable that we got from the user and to this function. Okay, here this function, imagine that this is not there. Okay, this part is not there. This function is going to calculate the equivalent of Celsius to Fahrenheit using this formula and return it. And the return value is stored in the Fahrenheit variable, and then we are showing this Fahrenheit in the output in terminal using the cout. Okay, but we had a condition here. We don't want the entered number by the user to be lower than this number. Okay, lower than this number, we don't want it to be. Therefore, we need to check if that entered number by the user is lower than this. We are going to throw an exception saying that temperature below absolute zero is not possible. Okay, then when this exception is thrown, we're going to catch that message here, and then we are going to show that message in the output. So let me run the code. So enter temperature in Celsius. So I would say the temperature is 2 degrees,
and it is going to show me this message in the output. Let me view. Okay, the degree is not showing correctly, not being shown correctly. So let me run one more time. So, okay, so it says enter the temperature in Celsius. This is the temperature in Celsius. And I enter 2. 2 is stored in the Celsius variable. And then we are calling this function Celsius to Fahrenheit. It is converting 2 to its equivalent in Fahrenheit, and it is returning the output. The returned output is assigned to the Fahrenheit variable, and then Fahrenheit variable is shown in the output, which is 35.6. Okay, so this is the temperature in Fahrenheit. So when I run one more time, I say, for example, 20, it's a temperature in Fahrenheit is 68. But if I type down, for example, minus 300, it is going to throw an exception. Error, temperature below absolute zero is not possible. So why this happened? The reason why is because we entered one number that is minus 300. It is stored in Celsius, and then we are calling this function and passing this Celsius variable, which is minus 300, to this function. And before doing anything, this if condition is checking minus 300. Is it lower than this number? Yes, it is lower than that number. Because it happens, if this statement is true, it is going to enter in this if condition and then throw an exception. This is the exception that it is going to throw. Error, temperature below absolute zero is not possible, and we are going to catch that error here. It's a string literal, that's why we are having the constant char pointer. Then we name it E, and we are counting the message E here, and we see it here in the output. We are having temperature below absolute zero is not possible. So basically, this is how we can have a conversion of Celsius to Fahrenheit with try, throw, and catch mechanism to make sure that the user is not making any mistake. Thank you for watching.